If you have finished your test work on site and exported the data into a USB driver, you will find a project named PDA data in your USB driver. It's the data from a HPT unit. You open it, you will find folders, and each folder means a project. The folder name is the project name. And you open one of the projects, you can see some files in it. These files are the HPT test file. Each file represents one pile. Today I will take this HPT demo as example to show you how to process data in case method software and matching software. So after you copy your data into your computer, you can just double click the file to open it if you have installed our software. Or you can open the file first, run the software first, and use file, open S01, and find the data. And also you can open it. This is the case method software. In this software, we do not do much analysis to the data. Usually we just use it to review the data and modify some information if needed. In this software, it calculates the data, it processes the data automatically based on the strain and acceleration we collect from the sensors. And in the software, we can modify the parameters we input on site if there are some mistakes. Here, in this area, we can review the input parameters and the output parameters. About input parameters, it's the project name, pile number, area, pile length, the density of the pile, wave speed, and JC value, and other information. We can modify these informations here. If you want to change the project name, you can change it here. And also the pile name, the area, the pile length, the JC value, and the specific weight, and the wave speed calculated, and the LP means the penetration depth of the pile. These are the parameters you input on site on the unit. If something is not accurate, you can modify here. And output, these parameters is calculated by the software automatically. You don't need to do anything about it, just to check. And here shows some parts of the parameters that the software calculated. Click selection, you can see all the parameters here, and you can choose which ones to show here. The one with a square block here means it's already be chosen to show. If you click it, to uncheck it, it will disappear. If you check it, it will show here. About the meanings of the software, I've made a table, and you can pause the video and check the details of these meanings. Usually, we will pay more attention on some of the parameters like FMX and CSX and RSP, RMX, and BTA, LDT, and TSX. Okay, after we select the parameters to show, and then we can check the data itself. Here is the graph area of the software. It will show the graph of the data. And in this area, you can choose which graph to choose because there are multiple graphs from the software. This is the original F and ZV curve. It is the most important, and usually we will check it. And here, wave up, wave down. And this we will show F, ZV curve and the wave up, wave down curve together. And also FZV with V1, V2, F1, F2, and V1, V2. This will show the original data, its strain and acceleration from our strain sensors and accelerometer. Here, FZV and the displacement curve, the red one, and the energy curve, the blue one. And also, we can show 3 groups of plots together. Usually, we use these graphs to judge if the data quality is good enough. For data quality, usually we have some things to check. First of all is the proportionality. Proportionality means the F and the ZV curve, they should meet each other before the first peak. For this data, it's good. If you find V curve and F curve does not meet each other, then there might be something wrong. And also, F1 and F2, the 2 channels of F and 2 channels of V, they should meet each other quite good. For this data, it's okay. They meet each other well. And the third, F and V curve should go back to 0, should return 0 at the end of the data. And this data is good. It's good. And we can go through all the 5 belows. In this file, we have 5 belows for this data. We can use this to go through all the 5 belows. And under here, it's we need to know that FF and VF, it's the filtering. It's for filtering function for the curve. For this data, it's from a steel pile, so there is a high frequency noise. You can see the high frequency noise. We can use FF and VF to make the plot smooth. Let's use 10. FF means filtering for force curve, and VF means filtering for velocity curve. Usually we use the same value for both. You can see that after we apply 10 for FF and the VF, the curve now looks more smooth. Also, we can use for other blows. And I will show you these icons. What do they do? The first one, T1 and T2, means we can move this line. The first line here is T1, and this one is T2. So we can click this one to move T1 to the left, and click this one to move T1 to the right. And this function usually we don't use because software will automatically find the correct T1 location. The T1 location should be the first peak of the velocity curve. And this one is T2. T2 means the end of the pile. We can move it using these two buttons. And you may notice that when we click these two buttons, these two lines are moving, and also the WC value is changing. That is because these two lines, the location of these two lines is decided by the first line plus 2L over C. If the L, that's the pile length, is fixed, then we will change the wave speed, calculated wave speed, to change the location of the pile bottom. Usually, we check the pile bottom on the curve. If there is a obvious reflection on the F curve or V curve, that is the pile end. If the reflection of pile end is not obvious, then we can check the wave up curve. Where the wave up go down, that is the pile bottom. So we put the first dashpot line at the wave up curve where it goes down. This is how we decide the pile bottom. And here, JC value is the only parameter that we need to determine by our engineer, because it will affect the capacity calculated by the software. For example, RMX and RSP. JC value is a value used for dynamic resistance calculation, and it's based on experience. So if we change this JC value, we can see that the RMX and RSP is changed. And this, because it's based on experience, so we cannot know the exact accurate JC value here. So that is the reason why we do not provide the final capacity results using case method. We usually use matching software to give the final result. These two buttons are used to move the plot together to the left or to the right. And these two are used to move the force velocity to the left or to the right. Because sometimes the F and V, they may not activate at the same time. There may be time difference between the two curves, so we need to modify using these two buttons. And these two are used to expand or shrink the data on the x-axis. And this two is to expand on y-axis. This we have showed that it's to switch between different blows. Okay, after we checked all the blows, and if we want to give a report using case method software, we can output DOCX output, save it, wait, it's generating the report. Okay, in this software here. This is the report from the case method software. It will export the plot we chose to show in the software. That is to say, if you choose other plots, it will export other plots. What shows here will report in the software. That's all for the case method software, PDAR. And the last thing we usually do with the PDAR software is to convert the file into another format for matching analyze, because matching software RCAPUP will read a different file format. So usually we choose from all the blows, we choose one blow to convert for the matching analyze. For example, we choose the force one, because the force one, I think the force, the energy is big. So we can expect higher capacity from this blow. So we click on file and save as S06. Usually I suggest you to name it with the blow number. The pile number with slash and 4. 4 means the force blow. Save. Then you will find a S06 file here. This file is used for matching analyze.